Hello Math 30-2. Today we're looking at rational expressions and equations lesson 5, which is adding and subtracting rational expressions, okay? It's not much different than the class before in adding and subtracting. We still need common denominators, except this time we're going to be looking at binomials as well, okay? So when we have binomials, so that means we still must make it a common denominator. And what we did was we did a multiplication, except here we have to do multiplications of sometimes binomials or binomial and binomial or binomial, so on and so forth. Now, the key thing to remember there is when we do this is our distributive property. So here we are, we're going to just jump right into it, into our first example. It says, first we want to find the non-permissible values. Anytime we're dealing with rational equations or rational expressions, we have to find our non-permissible value. So, for this first one, my NPV is equal to, we have two of them. We have 2x cannot equal to 0, and we have x plus 4 cannot equal to 0. So if I solve for both of these, let's take a look at this first one, divide by 2, I get x cannot equal to, well, 0 over 2 is 0. Or we could have, right here, this is 4, okay, plus minus 4, oopsie, this one should have been minus 4. So if I look at this one here, I add 4 to both sides, so I also get x cannot equal to 4. So those are my two non-permissible values. Now let's continue this out, and it says we want to simplify it. So to simplify, we must add these together. But what do we need to add them together? We need common denominators. So my common denominator here is going to be 2x multiplied by x subtract 4. All right. So in order to make this 2x, the denominator of this one, 2x multiplied by x subtract 4, I must multiply this by x subtract 4. So we have x subtract 9 all over 2x, and I must multiply the bottom by x subtract 4, right? But if I multiply the bottom by x subtract 4, I must also multiply the top by x subtract 4, otherwise we're going to have a different fraction. And we don't want a different fraction, so I multiply by x subtract 4. Okay? Now, x subtract 4 over x subtract 4 is the same thing as multiplying by 1, so it's the same fraction. We're good. Now, let's look at the next one. This one here, we're going to have to multiply this side, everything by 2x. So we get 3x multiplied by 2x, because the denominator is missing the 2x, right? And we have 2x multiplied by x subtract 4. Same idea. Here I multiply this really by 2x over 2x, which is the same thing. So we're going to combine this all together. Now that my denominators are the same, I can just add the tops. So we have 2x all over x subtract 4. Okay? Now the tops, I have to use my distributive property. So I want this x multiplied by x and negative 4. So it's going to give me x squared subtract 4x. Then I have to go to 9 multiplied by both of those. So that's going to give me minus 9x. And I'm going to have plus 36. Now, let's look at this one. Adding, we have 3x multiplied by 2x, which gives me 6x squared. Now I'm just going to have to simplify this. I'm going to end up getting 7x squared minus, combine these together, is 13x. I got the 7x squared by adding those two, combine like terms, plus 36 all over 2x, and then we have x subtract 4. There we go. Done. Now let's take a look at the next one. This one's a subtraction, a little bit different, but very similar. Okay, so we're going to start off by finding my non-permissible values. So, non-permissible values are, well, let's take a look at this. I have 2y plus 5 is equal to 0, like that one. Or we could have y minus 3. Oops, subtract 3 is equal to 0. Oh, and these cannot equal to 0. So this first one's easy. Y cannot equal to 3. I just added 3 to both sides, like we did before. The next one, we have to isolate for the y. So we have 2 is equal to, 2y is equal to negative 5. Take away 5 from both sides. And then we have now 2 y, or we divide both sides by 2, divide by 2. So I'm going to end up getting y is equal to negative 5 over 2. Okay? So these are my two non-permissible values. Now let's try and solve and simplify this, or just simplify something. So we're just going to simplify. Now to simplify, there's a subtraction, so that means we need common denominators. So let's make a common denominator. My common denominator, I'm going to say, is going to be 2y plus 5 multiplied by y subtract 3. So, we look at this first half. What is the denominator missing? It's missing a y minus 3. So I'm going to multiply both the 4 and the 2y plus 5 all by y minus 3. Okay? Because if I multiply by both of those, the same thing as multiplying by 1. To subtract. What is this side missing in the denominator? The 2y plus 5. So we have 1 over y minus 3. And we have to multiply by 2y subtract 5. Make sure we put our brackets in. Okay, now we have common denominators. So I'm going to make it all over. We can put it all over one thing. So here we have 4y subtract 3 subtract 1, and we have bracket 2y subtract 5. Okay? We're subtracting all that. All over 2y plus 5 all over y subtract 3. This is plus 5, plus 5. Almost made a mistake there, looking. That's plus 5, not minus. So let's multiply these in the top. So the 4 goes into both of those, so I'm going to get 4y minus 12. And now this negative 1 is going to be multiplied into everything there. Okay, so negative y, that gives me minus 2y, and it's negative 1 multiplied by the 5 as well, so that's negative 5, because it's negative 1 multiplied to everything. So we're going to end up getting, if we continue this, combine my y's, I'm going to end up getting 2y minus 17 all over 2y plus 5, and we have y subtract 3. And my non-permissible values, y still cannot equal to negative 5 over 2 and 3. Okay? Hopefully you got that. So, now we're going to look at stuff where we might have to factor to find common factors and stuff like that. Okay? So a little bit more complicated. So, let's take a look at this one. This one here, I can multiply, I can say my common denominator is, well, 10x, multiply these together, multiply this by this, but it might be a lot more simpler than we think. So first thing I'm going to do is, if possible, factor out the denominator. So my denominator here is going to be 4 all over 5 multiplied by x plus 1, because a 5 can be divided in both of these, and a 2 can be divided in both of those. Okay, so that's 3 all over, but notice it's still the same thing. We multiply that 5 in, it's still 5x plus 5. 2, and we have x plus 1. We look at that. That's very simple. We are very close to common denominators. And now like this, it makes it also easier to determine my non-permissible value. My non-permissible value is equal to 1, or negative 1. Okay? So that's my non-permissible value. Okay? So x, in other words, cannot equal to negative 1. So now let's try and solve this together here. What is my common denominator? I'm going to put those common denominator. Well, I'm going to say 5 times 2 is 10. So 10. And then we have x plus 1. All right. So I look at this one. Both of these have the x plus 1. This one here needs to be multiplied by 2 to get the 10. So we have 4. We have 2 over 2. 4. And we have 5 multiplied by x plus 1. Okay? Now we're adding. This one here must be multiplied that 2 by 5 to get the 10. So we're going to have 5 over 5 multiplied by 3 over 2 x plus 1. Okay? Now we're just going to simplify this out. So the bottom is now 10 x plus 1. And we have 8 plus 15, which will give me a total of 23. All right? So I have 23 on the top there. Okay, now let's try, and remember x cannot equal to -1. Now let's try this next one here. Now we have subtraction. Now before we do our non-permissible values, let's try and simplify this a bit so it's faster to do the non-permissible values. Now when we do this, we're not canceling off. You never cancel off to the end. So we're just simplifying and factoring. We don't cancel. It's very important. So we have 1 over x, that's simplified, subtract, 1 over, I think both of these could be divided by x. 1 over x, and then we were left with x plus 2. Now, this makes it very easy. My non-permissible values are going to put over here. We could have x cannot equal to 0, and this case here, x cannot equal to -2. Okay, so those are my two things x cannot equal to. Right? We make them equal to 0, and we solve. We learned that lessons before yet. So, let's try and solve this. What is my lowest common denominator? Well, we have an x here, and an x plus 2 there. Here we have an x, so it's just x plus 2. That makes things so nice. I don't even have to do anything to this side. It's already in the lowest common denominator. I only have to multiply that side by x plus 2. So, let's start this off. I'm going to have 1 over x multiplied by x plus 2 over x plus 2 is equal to, and we have 1 over x multiplied by x plus 2. Okay? So, it's not equal to. What are we doing? We're subtracting. I don't know why I said equal. So now let's try and combine this together. So I'm going to be left with x plus 2 all over, and we subtract 1, all over x plus 2. Right? Well, this combines to be x plus 1 all over x and x plus 2. That's it. And we know my non-permissible values can't be those, 0 and -2. Okay, let's take a look at our next question, our very last question. We have, a student was asked to write a rational expression for this here. Okay, and he also was asked to indicate the non-permissible value. Okay, so we're going to simplify this and find the non-permissible value. He started his work, but he didn't finish. So let's see how well he did so far. So first thing he did, he looked at this and he said, I could factor out something from both of these. He factored out a 3 from this here. Both these could be divided by 3. And a 4 from this here. Okay? So he's left with this. Now he looks at these could be similar. He likes his x being positive. If one's positive, one's negative, he wants his x to be positive. So he took out a -1 there. So now it's positive. That's good. There we go. Now, can you find the lowest common denominator and the non-permissible values? Well, my non-permissible values here is, I'm going to write up here, my non-permissible values is x cannot equal to 3, because we just have to make that equal to 0, right? And this is the same as that. Now, what is my lowest common denominator? Okay, so lowest common denominator is equal to, well, we have the x minus 3 in both. Now, I have a 3 in this one and a 4 in that one. So that's 3 multiplied by -4. That's my lowest common denominator. Okay, so we need this to have that lowest common denominator, and we need this to have that denominator. So let's try and write this up. I'll go back up here and write this up. So we have is equal to 2x all over 3x minus 3. Now, what are we missing from this one? I'm missing that -4 right there. So we're going to multiply by -4 over -4. Now we have common denominators. It's a bit closer, and we're adding. Okay? This one here is missing the 3. So 3 over 3, and I have x plus 5 all over x minus 3. Okay, so now my denominators I know are the same. Oh, and there's a -4 there. Forgot to put that in. So it's all over. 3 and 4 is -12, and we have x subtract 3. Okay? Now this here, I'm going to multiply this together. This is going to give me -8x. Okay? Now we're adding, so it's plus 3 multiplied by x is going to be 3x. And plus 3 multiplied by 5 is going to give me 15. Oh. 15, 3, that's the plus 15. Okay? So we're going to get that. We get plus 15. Now, let's combine these together. If I combine them, what am I going to end up getting? I'm going to end up getting 5x, negative 5x, plus 15, all over negative 12, and we have here x subtract 3. Now, I look at this, I have a negative and a negative. Do I like those being negative? No, I'm going to simplify it a bit more. This is essentially the same thing as, if I take out the negatives, divide everything here by a negative and a negative, because I want to take out a negative out of all of this, so that changes both signs. So if I make that negative 1, this turns into a negative instead of a positive. So what's that going to be left with is, that negative 1's out, we're going to have 5x, subtract 15, all over 12, and here we're going to have x minus 3. Okay? So basically, I factored out a negative 1 from the top. So it's negative 1 multiplied by all of that. Here, it's only the 12 that has the negative, so I can just factor out the negative from that, because it's already being multiplied to that. So this 12 being multiplied in would do the same thing. Consequently. So now I look at this, I can factor out a 5 as well. So I'm going to take out a 5, and I'm going to be left with x plus 3 all over 12, x subtract 3. Okay? And I'm going to continue this. What does this give me? These cancel off, so I'm left with 5 over 12 is my answer. But remember, x still cannot equal to 3. Okay? So hopefully you get that. X still cannot equal to 3, but my answer is 5 over 12. So hopefully you get that. As I see you tomorrow, we work on this together.